All right, welcome back to pre-calculus. We are continuing our discussions on systems of three equations. This is just number two, and they pretty much gradually take us up like through the levels of difficulty here. So this problem, it says solve the following systems, but this is already in what we would call like lower triangular or upper triangular format. So if I was going to rewrite this just a little bit, no, get rid of you. I don't want to go on any of this. That's what I wanted, lecture notes. Thank you very much. Okay, we'll sort you out. Normally what I would do, why is this not a fit? Okay, there we go. Okay, so what I would write this down as is 5x, 5x plus 6y minus 6z is equal to minus 9. The second equation looks like 5y plus 3z is equal to 4. And the last one is z equals 3. And you see how this kind of makes a triangle here? So the fact that it's fact that it looks like a triangle that looks like this. Okay, we call that upper triangular. If you write it backwards, if you write them upside down, so if I write it the other way around, we'll end up with a triangle that looks like that. It's called lower triangular. Upper triangular. This is going to be a goal for us to solve the equation. It doesn't matter which one you prefer. I prefer upper triangular because that's just the way I'm used to doing it. But if you want to prefer a lower triangle, it makes absolutely no difference whatsoever. Okay, and it really doesn't mean some. If you ever take a class called linear algebra, like they might care which one you call which, but for the most part, it's in upper or lower triangular form. They're really equivalent. It doesn't really matter. Okay, so once you've got it in this situation, the idea is eventually we're going to go through and do elimination on these to put the equation in an upper or lower triangular form, and then we're going to back substitute in to get to the rest of them. Okay, so what we have here is we have z is equal to 3. So once I know that z is equal to 3, okay, we have equation A, B, and C. What I'm going to do is I'm going to take the solution I have for equation C and I'm going to insert it into equation B. So we have 5y plus 3z is equal to 4. Once I know that z is equal to 3, we have 5y plus 3. What was z again? 3 equals 4. So this isn't too bad. So this is 5y plus 3 times 3 is equal to 9. 4. We'll subtract 9 from each side. So we have 5y is equal to 4 minus 9 is minus 5. Divide both sides by 5. And we'll have ourselves our y is equal to negative 1. So we have two variables here. We have z is equal to 3, which they kind of gave us for free. Okay, y is equal to negative 1. You can see that. Okay, I've got to get my handwriting to be a bit better. And then, so yeah, system area agony, have the last laugh. And then we go back and we say, well, we have 5x plus 6y minus 6z is equal to 9. So we already know what x and y are. We already know that z is equal to 3. So we're just going to say this is minus 6 times 3. We have 6. What's y again? Y was negative 1. Okay, we have 5x plus all of this equals to 9. So what we're just going to do is we've inserted these things in here. So we have minus 18, have minus 6, and we have 5x equals 9. So what is this? 8 and 6 is minus 24. So we have 5x equals 9. So we're going to add 24 to both sides. Okay. So this is not really liking this because this is usually a little bit easier than what we have here. So I'm just going to double check. So usually Usually they're very nice about what kind of solutions they have. They don't have to be. These could be horrible fractions, but so be it. So we have 5x is equal to 9 and 24 should be 3. So x should be 33 fifths. Just leave it as such. We can check this, but the requirement isn't that we check it in case we just figure that out. Okay. So we are going to have our summary. We're going to say x is equal to 33 over 5. Y is equal to, go up here, we see -1. And then z was equal to 3, because that's what they gave us to begin with. And I'm just going to write this in and cross my fingers and hope for the best. So this is 33 fifths. Okay. This was -1 minus 1. And this one was 3. And if I get if I get this wrong, I'm going to wonder. Okay, your answer is incorrect. Your x is incorrect. That makes sense. At least the y's were correct. So we'll just double check our y's here. So we have 5x. Okay, I'm glad they don't penalize you, don't make you do the whole thing. 6z equals -9. I'll bet that's where the mistake was. So we have 5x plus 6 times -1 minus 6 times 3 is equal to -9. I think that's where it was, wasn't it? But that's where it was. So we have 5x, okay, minus 6 minus 18 equals -9. That's still going to be -24 equals -9. 5x, we'll add 24 to both sides, add 24 to both sides. Let's see, 24 minus 9 is going to be 14. It looks like 15. Okay, this sounds a little bit better. I like 5x is equal to 15. And then we'll have x is equal to 3. So let's see here. I'm going to double check this because my arithmetic kind of sucks at this point. So we're going to go ahead and say -9 minus 24, or no, plus 24. So I'll get it wrong again. So we're just going to double check it. Hey, look at that, 15. I was good. Okay. So we'll say x is equal to 3. So we're just going to go ahead and change that. I'm glad they didn't penalize us too much, make us do the whole thing over again. We'll try it again. Okay. And now we have the green check and we seem like we're going to be okay. Okay. So that's pretty much what we're doing. It's one step above verifying it. So if you're looking at this like, this seems kind of easy. Like it's supposed to, it'll get hard before too long. Okay. I promise it will get hard. Like for this one. So I'm going to go ahead and close out this video so you guys don't have to watch a little bit for each one, and we'll do the hard one next. Okay, thank you, and I'll see you in the next video.